This is the pre-lab section of Lab 1. This is problem number 1, where I1, I2, I3 are the intermediate outputs with the mathematical equations next to it. And here are the behaviors of the intermediates. This is problem number 2. This is a NOT gate. So with the input of low, you get a high. And then input of high, you get a low. This is the OR gate. You have two highs, your inputs A and B. So two highs gets a high, one low gets a high, and then two lows gets a low. This is the AND gate. You have a high and a low here. That gets you a low. Change it to two highs, get a high, then vice versa. If this is a low, this is also a low. Then for problem number 3, this is the 2 to 1 mux. So I'll be testing the 3 inputs. So for all high, you get a high. For A and B is high, selector is low, you get a high. And for A and selector high, you get a low. This is my Tinkercad version of it. Testing this, it's all high. And then if you move the selector to low, still turns on. If you move B to low, it should turn off. There you go. And finally, this is the 4 to 1 mux using 2 to 1 multiplexers. So this is the in-lab portion of Lab 1. So in this initial state, everything is at 0 or low. Now I'm going to move A to high. Now I'm going to move B to high. I move the selector to high. Now state 2, not state 2, A and B are high. Now A and the selector is high. And then B and the selector is high. Selector is high, B is high. Okay. And then finally, everything is high. That's it. This is in lab for lab 1, question 2. Right now, the selector is on high. So it's operating with the behavior of B, which is at 0.5 hertz. If we switch it to 0, operates at 10 hertz.